All right, how to find the domain and range of a function. And I guess I shouldn't have function there, I should have relation because some of these will be functions, some of them will be relations. You just have to find the domain and range of the specific situation. And graph the function, and then, usually this is the directions you see in most texts. So they'll say graph the function, state the domain and range. All right. So we're going to go ahead and I'm going to give you some relations, and we'll look at all of these. First off, what is domain and range? Domain generally is thought of as your x values in an ordered pair. So if you had this nice relation written like this, so maybe 5, 2, 6, 1, so it just gives you it as a set of just specific ordered pairs, -2, 4, you can do one more, 8, 2, and that's all that we have paired up in our relation. Well, then that's pretty simple. My domain in this case would be the 5, the 6, the -2, and the 8. And my range would be 2, 1, and 4. You wouldn't have to list that 2 again over here. So that would be your domain and range. So not too difficult. But what if it listed it as an equation? So let's say you had something like this. X squared plus y squared equals 8. Or, and I'll just kind of list them all out here. Y equals 2x plus 1, and we'll look at all of these cases. Now you could, and let's put it over here. So let's say I had the absolute value of 2x plus 1 as the next function or next rule to look at, or relation. Or you could have something like this: y equals x squared plus 5x plus 4, a quadratic. Or you might have a rational equation like this: so 2x over x plus 5, x minus 2. Okay. So, and maybe one more. We'll do one more here. So this one always kind of gets people: the square root of x minus 4. All right. So those are all relations that we're going to hopefully quickly go through. And to speed things along, I'm going to use GeoGebra. So you could go through and make a table and plot these by picking values for x and finding y, but that's going to take too long. And I encourage you to use GeoGebra. So the first thing I would do here is we'll just go ahead and do that first one. And I'll just kind of show you what it looks like. So I'm going to type these in so that you can see how I'm doing that. X squared plus y, I'm using a caret, it's above the 6 key usually on your computer. X squared plus y squared equals, and I said 8. I'll graph that. And if you notice, it's a circle where and I guess I should have picked a nicer one, but that's okay. So notice it hits out here, on the x axis at about -2.83 and positive 2.83. On the y-axis, it looks like 2.83 positive and -2.83 there. Well, 2.83 is the square root of 8, or 2 root 2. So, in our case, the domain of this value, or this relation, this is not a function. So the domain are all numbers from -2 root 2, all real numbers, from -2 root 2 to x to positive 2 root 2. And so that's the domain. So, wow, that's going to get all scrunched up. Range is the same, because on the y-axis it starts at -2 root 2 and goes to positive 2 root 2. So I'll pull that back up so you can kind of see. So my domain starts here, ends here. My range starts here, ends here. And so you've got, for the range, you've got the numbers from -2 root 2 is less than or equal to y is less than or equal to 2 root 2. So that's this set here. The circle doesn't, that rule doesn't allow you to use any other numbers but the numbers between those values. Okay? So, alright. Alright, so let's look at y equals 2x plus 1. Okay, in GeoGebra that one types in pretty quickly. So, y equals 2x plus 1. Oops. You type it in, it's that straight line, and I'll get rid of this circle for us. And if you notice, it goes down all the way, goes up all the way, and you could follow this thing forever in all directions, going all the way left and down and all the way up and right. So there are no values to restrict in this case. So your domain and range, so your domain would be all real numbers. And you know, there's symbols for all of this, but I'm not concerned with this. I'd be more interested in that you just understand how to find domain and range of a function if you don't quite get to the symbols. So that's domain. You can use all real numbers. And the range is also all real numbers. And I'll use the number sign. So there's your domain and range. So sorry that's kind of nasty. But let's change it. Let's put an absolute value on it. So I'm going to go to a fresh page. So if you had y as the absolute value of 2x plus 1, and close it with the absolute value symbols, that's going to change a little bit, and let's take a look at that. So when you took a look at that, y equals, and you use ABS and then a parenthesis, 2x plus 1. And take a look at the V it makes. You know, and I'll hide the previous one so we're not getting confused with it. There it is. So notice it doesn't go below the x-axis. So your y values start here and go up. So that's your range. Now your x values go as far as you want to the left, ooh, and as far as you want to the right. Back and forth. So, and you could follow that around, you know, follow it as far as you want to follow it. But this is the important part of the graph. So, in that case, our domain, which is the x values, those are all real numbers. And our range is the values of y such that y is greater than or equal to 0. So it could be 0, but it's never going to be negative because of the absolute value. Okay? And some of this you can, you know, if you know your mathematics well enough, you can kind of logic that out. So let's look at y equals x squared plus 5x plus 4. So y equals x squared plus 5x plus 4. So you plug that into GeoGebra, and hopefully by now you're kind of getting the hang of this and understanding what's going on. So y equals x squared plus 5x plus 4. Hit enter, and you notice the parabola it forms. And I'll move the graph so we can take a look at that in a little more detail. Hide the previous function. Whoops, that's not it, that one. And what you have, get rid of them points, they're kind of in the way as well. So what you have is this bottom point, the vertex, that's down here, and it looks like negative 2.5 and negative 2.25. So our range would start here and go up from there, from negative 2.25. So it's all of those values. Now domain, notice left and right again, it's going to keep going on and on forever. And so that's, our domain is all real numbers, which you'll find happens a lot of times. Okay, so domain x is all real numbers, the x values. I'm getting kind of lazy here, but range would be the numbers such that y is greater than or equal to negative 2.25 or 2 1/4. Now, there's formulas to figure out exactly what that is, and we're not into that today. So, but there's your domain and range for that function. So back to this one, this bottom one, and I've showed these last two for a specific reason. They get kind of crazy looking. So I'm going to extend the page down a little bit. I guess the one on the right isn't too bad. But the one on the left, when you plug that into GeoGebra, you want to be pretty specific. So I'm going to hide that so that we just have our clean slate again. And we're going to enter this, and you got to be really careful. So you enter y equals 2x in parentheses, and I always kind of group it in parentheses like that so that we know that the 2x is all on top. You wouldn't need them there, but on the bottom it's very important that you have them. Divided by, and in fact, I'm going to use two sets of parentheses, x plus 5, and then x minus 2, and then close the whole bottom parentheses. If you didn't do that, then I'll take the one set of parentheses out so you can see what it looks like. Sometimes it works, and let's see if it changes then. So, and I'll just click on it and change it here. So if I put a parenthesis there, in this case maybe it recognizes it now. Oh no, yeah, it definitely changes it. The second one I just did is correct, and I figured that was the case, but they're updating this all the time, and maybe they programmed it to recognize it. They haven't, which is good. So it follows kind of the programming language. But this is kind of a crazy looking graph. So let's zoom out a little bit to see what's happening. So with a rational function, you have things, they're called asymptotes in mathematics. But if you notice here at 2, you could draw a dotted line, and this graph, even though I'm terrible at drawing a straight line, this graph, or this particular one, is not going. It's going to go up there and approach 2 but never reach it. And the same with this one. It's going to approach 2 but never reach it going down. Over here, you can look right here at 5, if I could hit 5, and it does the same thing. So these are like holes in the graph. And so let's take a look at that. Oh my, let's minimize that and hopefully it disappears. Yes. So the holes in that particular graph, well, notice what happens. If you had x equals negative 5 and you plug that in there, you'd have negative 10 on top and then 0 times negative 7 on the bottom. Well, negative 10 divided by 0 is undefined. I'll put the empty set. That's an undefined value. So it doesn't work there. You don't get a real number. And the same with 2. So again, there's probably, there's lots of mathematical symbols for that, but I'm more interested that you just understand what the concept means. My domain is all real numbers, like before, except the 2 I just listed, except when x is equal to 2 and when x is equal to negative 5. So sometimes it'll say x cannot be 2 and x cannot be negative 5. And now my range, I kind of skipped over that, but the range in that case is all real numbers. Nothing is excluded in the range. It goes on and on forever up and on forever down. So all real numbers there. And then the last one is the square root of x minus 4, which is good. So that because we're getting kind of long. And so for that particular one, oops. We are zoomed clear out now. That's alright. We'll get it figured out later. So y equals SQRT for square root. And I think it was x minus 4. And then I'll close my parentheses and hit enter. And get rid of that g at x. There we go. And so if you notice, we've got, I'm going to zoom in here so that we can kind of zoom into that spot. If you notice, it starts at 4. And let me get rid of some of this so we can look at it a little closer. And so notice it starts right here, and my domain goes all the way to the right. And my range also starts there and goes all the way up. So that has a couple different meanings then. So my domain in this particular case is all real numbers where x is greater than or equal to 4. And my range is all real numbers where y is greater than or equal to 0. Because it starts here at 0 and heads up. So I hope that helps. Again, if you have questions, just put a comment down the bottom. And see you next time. Good luck.